Hi everyone. I'm creating, sorry, something I had to do. I'm creating this short recording just to talk you through what exactly we're looking for now. Again, when we're doing these truth tables. So the prior lessons, go Chargers, the prior lessons were about what the truth tables are, why we use them, um, the whole nine yards, and how to execute them. But I wanted to have just a conceptual conversation with you about what you're looking for. Okay? Remember, and this is going to be, I'm going to be sort of reiterating points that we made in the first weeks. Remember that when it comes to reasoning, when it comes to thinking, there's two kinds of thinking that we do. We do inductive thinking and we do deductive thinking. And inductive thinking or inductive arguments are arguments where our premises are supposed to make our conclusion likely to be true but not guarantee it. And deductive reasoning or deductive arguments is where our premises are supposed to guarantee our conclusion. The work that we're doing in Chapter 10 is about this guaranteeing the conclusion. Do the premises of an argument guarantee that the conclusion will be true? That is, if the premises of a deductive argument are true, do they guarantee that the conclusion will be true? Whether that's the case or not has nothing to do with whether with the content of the argument. It has to do with the form of the argument. It has to do with how true and false claims relate to one another rather than what they talk about. So, what we did in this chapter and what we've been doing in this section is to get rid of the content of the arguments and isolate just their form. And we did that by substituting single capital letters for the content and substituting in these symbols for the operators. The operators describe the relationships between claims that form complex claims. And complex claims have a truth value that is independent of the truth value of its constituents, but determined by them. Okay? So whether a conjunction is true is dependent upon the truth values of each of its constituent claims and that specific operator. So with that in mind, we've set up these truth tables, and the purpose of the truth tables is to see every possible combination of true and false for an entire argument. And why would we do that? Because we want to know, going back to the definition of validity, we want to know if it's possible for all of the premises to be true and the conclusion to be false. That's why we lay out every possible combination of true and false, because we want to know if it's possible for all of the premises to be true and the conclusion to be false. And if that is possible, if we can have all true premises and a false conclusion, if that's possible, the argument is invalid. In a valid deductive argument, that is not possible. In a valid deductive argument, every time you have all true premises, the only option is a true conclusion. So we're doing these long truth tables. We're doing these truth tables looking to see if we can get true premises and a false conclusion. That's why we're doing 8 lines, 4 lines. I haven't done any examples, but if we had 4 terms, there would be 16 lines, which would be just a god-awful, ugly mess. And on your test, you may have some that have 4 or 5 terms, which would be anywhere. What is 2 to the 5th power is 2 times 2 is 4 times 2 is 8 times 2 is 16, 32 lines. Now, don't panic. I'm not going to actually ask you to complete 32 lines. The lesson for next time, the next lesson, which occurs in the next week, is how to do the short truth table method so that you can solve these sorts of problems in a single line. Nonetheless, That's what we're after. So um, the reason why we're laying out every possible combination is to see if it's possible to get true premises and a false conclusion. And if it is, then the argument is invalid. Then we know that even if all of your premises, your argument was true, your inference is bad, and this is a bad argument. So that's the work that we're doing. That's why we're doing it. That's what we're looking for. And that's the purpose of this sort of exercise, okay? And we can turn it really, deductive arguments function very much logically, very much like math. And in fact, what we're studying here with the operators and the truth values is really very much like a coding language. It's a binary system of ones and zeros, one being true and zero being false, with certain operators that determine the value and on-off for more complicated arguments, they call them in programming. So we're learning something that's extraordinarily useful and common actually to a whole different, a whole world of computer programming. Anyways, that's the purpose, that's the function, that's what we're looking for. And so if you have any questions, shoot me an email, let me know, and I will be glad to get back to you and answer any questions you have. But there you go. That's it for this lesson.